Hey everyone, welcome to my channel. So today we'll be solving another problem in our DSA warm-up series, and this problem is called robot return to origin. So in this problem, we'd be given the initial position of a robot, which is the origin 0, 0, and as an input we would have a moves string which would contain any of these four characters. So U denotes the upward movement, D denotes the downward movement, L denotes the leftward, and R denotes the rightward. So this is our input basically, and the above one is actually given in the question. So you would have you would be given, or maybe you can assume your robot is at the origin, and then after your robot has accomplished all of the moves in this string, we need to determine whether the robot has returned to the origin. So which means, for example, let us consider a 2D plane, and this is a Cartesian coordinate system, and we would have a robot at this place, which is the origin. So this is our robot, and what our robot needs to do is to follow each and every instruction, and then once it has executed all of these set of instructions, we need to figure out whether the robot has returned back to this position. So for example, for this given value, we have to take upward movement first, and then we need to do a downward movement, and with that our robot has returned back to the origin. So this case we get a, or we return a true value. Now let us assume something like maybe LLR or something like that. So in this case our robot first takes a leftward movement, and then another left, and then a right, so it comes back. Okay. So here is the new coordinate of our robot after executing this set of instructions, and it is -1, 0. So this is clearly not the origin, and so in this case the result would be false. So now the question is, how do you solve it? Well, it's pretty easy. I would urge you to pause this video and think it for a while and see if the solution matches whatever you are thinking. So for example, to begin with, we'd have a set of coordinates or set of variables that denotes the x and y coordinates. So for x, we would have 0. For y, we would have 0, right? And now what we need to do is we need to execute each and every instruction in these moves string, right? So we have to loop through the moves array. So for every move in the moves array, we need to see how we manipulate these x and y values, right? So first case would be, for example, if the move is equal to something like u, right? What we need to do here. So for an upward movement, the x value remains same, but the y value increments. So this particular place is 0, 1, right? Right here it is 1, 0. This I have already written. This is -1, 0, and this one is 0, -1, right? So for an upward movement, we see the y value increases whereas the x remains constant. So we would increment y in this case. For the second case, when the move is maybe downward, it's the opposite of upward, so it will be y decrement. And for the third case, we have move equal to, for example, let's say I'll take L. You can very well put this in any order, so the order really doesn't matter. So for leftward movement, we decrement x now. We do not increment x, we decrement x. But whereas for the rightward movement, we do increment this x value. So with all these cases done, our robot would eventually land up in a place with a new set of values for x and y, and we need to figure out whether x and y is equal to 0, and that would be our condition, or the result, right? So if x is equal to 0 and y is equal to 0 after all these instructions have been taken care of, we can return very well the result of this expression. So if, for example, for this particular case, the first one, the x would remain constant and the y would increase. So it would be for the first step. So if it is u and d, so we'll see for u, our coordinate becomes 0, 1. We are incrementing y. For d, we are decrementing y. So at the end of this instruction, we get 0, comma 0. So this is true in this case. For L, L and R, what we do is we take first L. For L, we decrement x. So x decrement means -1 and y remains the same. R, sorry, there's another L, my bad. Another L would mean another decrement of x value, so -2, comma 0. And another R would mean increment, so -2 plus 1 is -1. So this is the final result, final coordinate of our robot, and it is not equal to origin, so this should return false. So that's it. I hope you were able to guess it, and this is it for this problem. This is a warm-up problem, I know, and this is pretty easy. So that's the intention of doing this warm-up problem, so that you guys can like practice and understand some of the concepts which we would be using in solving the other problems, right? So if you go to my YouTube channel, you'd see I've created playlists depending on the DSA patterns, and I'll be creating more such playlists in the future. So I hope you really liked this one, and do suggest me if you have any questions or queries, or you need me to do anything extra or anything else, to let me know in the comments. I'll be happy to incorporate those suggestions. Yeah, that's it. Thanks everyone. Bye bye.